Proxima Centauri is the star closest to our solar system. Astronomers have been interested in it for a long time. Robert Innes, a Scottish scientist, found this small red dwarf in 1915. It is part of the Alpha Centauri system, which also has Alpha Centauri A and B. Even though it is only 4.24 light-years away, you can't see it with the human eye because it isn't very bright. But Proxima Centauri is very important to science, especially since it is the host star of Proxima B, an exoplanet that circles within the star's habitable zone. It takes red dwarfs like Proxima Centauri a lot longer to die than stars like our Sun. It's hard to see them because they aren't very bright, but that also means their livable zones are closer to the star. This means that Proxima's circular distance is only 0.05 astronomical units, which is a very small part of the distance between Earth and the Sun. Because it is so close, Proxima B is subject to strong stellar activity, such as solar flares and high radiation levels. This makes its climate very different from Earth's. Finding Proxima B was a huge step forward in the study of extrasolar planets. Astronomers used the radial velocity method to find small changes in Proxima Centauri's position that were caused by the pull of a planet orbiting it. Scientists were able to figure out the planet's mass and rotational period by looking at these wobbles. The European Southern Observatory officially confirmed the presence of Proxima B in 2016. This was a big step forward in the search for worlds beyond our solar system that might be habitable. Observations from the ground have given us useful information about Proxima B, but they also have big problems. Earth-based cameras can't get very good images of the planet's surface or atmosphere because of light interference and the way the atmosphere bends light. We know most of what we know about it, like its mass, how far away it is from the star, and how its orbit works, from readings that were taken from other sources. More improved observational tools, like the James Webb Space Telescope, JWST, are needed to find out more about Proxima B's environment and whether it could support life. Proxima Centauri is a key to understanding systems with planets outside of our solar system. Since it is the nearest star system to Earth, it provides a unique chance to study the conditions needed for life. Proxima B, in particular, is a fascinating possibility. It could be a hard planet about the size of Earth that could hold water and maybe even life. But because of how harsh its environment is, it's hard for experts to figure out. A doorway to the universe, the James Webb Space Telescope is more than just another astronomy tool. It is a change built to replace the Hubble Space Telescope. It was planned that JWST would fix the problems with its predecessor and expand what people know. Hubble's focus on visible and infrared light limits what it can do, even though it has given us a lot of useful information about the universe, like how old it is and how thousands of galaxies were found. JWST, on the other hand, is designed to look at the universe in infrared wavelengths. This lets it see through cosmic dust and find things that Hubble can't see. One of the most important parts of JWST's design is its main mirror, which is an amazing 6.5 meters across and more than twice as big as Hubble's mirror. With this bigger mirror, JWST can gather a lot more light, which lets it see things that are very faint and far away. The mirror is made up of 18 hexagonal pieces that work together to make a very sensitive platform for observation. It has a thin layer of gold on it to make it reflect infrared light better. The 5-layer sunshield on JWST is another groundbreaking invention that keeps the equipment of the telescope at a constant temperature of -233 degrees Celsius. This very cold climate is important for picking up weak infrared signals without the telescope's own heat getting in the way. Each layer of the sunshield is made of a special material called Captain that has metal on it to reflect light. All of these things make JWST the most advanced space telescope ever made. Hubble goes around the Earth, but JWST works from the second Lagrange point, L2, which is a stable spot about 1.5 million kilometers away from Earth. In this spot, Earth's heat and light cause the least amount of interference, so JWST can keep making measurements. The telescope can look at everything from the earliest galaxies to the atmospheres of exoplanets like Proxima B from L2. Its focus on infrared light is very important because it lets astronomers study redshifted objects, which are things whose light has been stretched to longer wavelengths as the universe expands. It is possible for JWST to do a lot more than just observe. Its goal is to find answers to some of science's biggest questions, like where galaxies come from, how stars are made, and what conditions might be needed for life to exist on other worlds. JWST is more than just a telescope. It has cutting-edge tools like the Near-Infrared Camera, NIRCam, the Mid-Infrared Instrument, MIRI, and the Near-Infrared Spectrograph, NIRSpec. It's a time machine, a lab, and a shining example of how creative people can be. Proxima B has caught the attention of both science and the public as a possible second Earth. The planet is in the habitable zone of its star, which means it has the right conditions to support liquid water, which is necessary for life as we know it. Proxima B is probably a hard planet like Earth because it has a mass about 1.17 times that of Earth. It is just over 4 light-years away from Earth, which makes it a great place to look for signs of life in other solar systems. On the other hand, Proxima B is not at all like Earth. One of the most interesting things about it is that it is tidally locked, which means that one side of the planet is always daylight and the other side is always dark. This makes a unique setting where the two hemispheres have very different temperatures. The Terminator line, which marks the edge of day and night, may have a small twilight zone where conditions are just right for life. The world around Proxima B presents big problems. A red dwarf star called Proxima Centauri is its host star. This star is famous for its strong solar flares, which can send out bursts of X-rays and ultraviolet radiation. Over time, these flares could get rid of the planet's atmosphere, leaving its surface open to the roughness of space. Proxima B probably needs a strong magnetic field to protect itself from radiation if it still has an atmosphere. The surface world would be dangerous for life as we know it without this kind of protection. Scientists are still hopeful that there could be life on Proxima B, even with these problems. The planet's location in the habitable zone means that liquid water could exist on its surface or in pools below the surface. Extremophiles are organisms that live and do well in harsh environments like deep-sea hydrothermal vents or high radiation zones. Life might be able to adapt to the harsh circumstances. Some examples of these changes are resistance to radiation, living in the ground, or having special biochemical processes. There is more to the search for life on Proxima B than just science. It is an attempt to answer one of the greatest questions people have ever had. Are we the only ones in the universe? Proxima B is a tantalizing possibility. It's a rocky world like Earth that might have the right ingredients for life. As our technology gets better, we can learn more about this fascinating world and find out what it holds. Proxima B has a lot of interesting options, but its environment is deeply affected by the way its host star, Proxima Centauri, works. Proxima Centauri is not like our Sun. It is a red dwarf star, which means it is smaller, cooler, and not nearly as bright. It is much smaller and warmer than Earth, so its habitable zone is much closer. Proxima B is pulled into an orbit just 0.05 astronomical units from the star, which is about 20 times closer than Earth is to the Sun. This closeness makes things difficult for the planet and any life that might live there. Proxima Centauri's star activity, especially its strong and frequent solar flares, is a big problem. These flares are sudden, strong explosions of energy that send out a lot of X-rays and UV light. Red dwarfs have a lot more and stronger of these kinds of events than stars like our Sun. This means that Proxima B is constantly hit by high-energy particles, which could damage the planet's atmosphere over time. If Proxima B didn't have a magnetic field to protect it like Earth's magnetosphere does, any atmosphere there would be easily worn away, leaving the surface open to the harmful radiation. The radiation from Proxima Centauri is very dangerous to life, even if Proxima B keeps some of its atmosphere. Ultraviolet radiation at high amounts can break molecular bonds, which stops complex organic compounds from being made. It would be very hard for life to grow or stay alive on the planet's surface because of this. On Earth, living things like Deinococcus radiodurans have developed ways to fix DNA damage caused by radiation. This makes it possible that life on Proxima B could also respond in the same way. But the amount of radiation resistance needed would be very high, which might mean that completely new biochemistries are needed. It's interesting that Proxima B's tidally locked state may provide some safety. One half of the world is constantly hit by radiation from Proxima Centauri, but the dark side could be a safe place to be. Deep caves or shelters below the ground could protect possible living things from the worst of the radiation. Also, if Proxima B has oceans below the surface, they might provide a safe, radiation-free space where microbes can grow and thrive, similar to the ecosystems that form around hydrothermal vents on Earth. Scientists are still hopeful despite these problems. The harsh environment of Proxima B makes it a unique place to study how living things can adjust. Researchers can learn more about what makes a planet habitable by watching how organisms might live or even thrive in those conditions. Proxima B is more than just a possible place to live. It's a life itself can be used as a natural laboratory to test its limits. A lot has changed in the search for life on other planets, especially ones like Proxima B, thanks to the James Webb Space Telescope, JWST. One of its most useful features is its infrared spectrography, which lets astronomers look at the chemicals that make up a planet's atmosphere. Scientists can find important signs in the atmosphere, like water vapor, carbon dioxide, methane, and oxygen molecules, by looking at how light reacts with these molecules. These molecules are often linked to biological processes. Spectrography works by breaking light into its individual wavelengths. This makes a fingerprint that shows which elements and chemicals are present. For Proxima B, this way could find out if the planet has an atmosphere and what might be in it. Having gases like oxygen and methane together could be a strong sign of biological activity, since these molecules tend to react and break down without being replaced by living things all the time. The red edge is an interesting biosignature that scientists are looking for. On Earth, plants take invisible light for photosynthesis but reflect infrared light, which makes a unique spectral trait. If Proxima B has organisms that are like plants and have adapted to its climate, they might give off a similar red edge signature in the infrared spectrum. Finding this kind of signature would be strong proof that there is life on the world, or at least photosynthetic processes. The search has taken on a new level since flickering lights were found on Proxima B. These lights might be natural events like volcanoes erupting or auroras caused by the star's rays. They could, however, also mean something more strange: artificial signals from a smart society. If it turns out that these lights are not natural, it could be the first proof of alien technology, which would be a huge discovery with huge effects. The findings made by JWST are just the start. Future projects, like the planned Habitable Worlds Observatory, will build on what JWST found to make them even more sensitive and accurate. The next wave of telescopes will be able to take direct pictures of exoplanets, showing us their surfaces and atmospheres in great detail. All of these improvements are making it easier for people to answer the age-old question, are we alone in the universe? There are billions of galaxies in the world, and each one has billions of stars and maybe trillions of planets. With these mind-boggling numbers, the chance of life, clever or not, seems high. Even though people have been looking for decades, they have not found any solid proof of alien civilizations. Where is everybody? Physicist Enrico Fermi famously asked, which is how the Fermi paradox got its name. One possible answer for the Fermi paradox is that intelligent civilizations are very rare. Microbes may be common, but it might be very hard and rare for simple organisms to evolve into advanced, spacefaring societies. On the other hand, civilizations could end themselves before they can reach other people. The past of nuclear weapons and damage to the environment is a sobering example of this possibility. Another idea is that more advanced civilizations avoid interacting with less advanced ones on purpose. The Zoo hypothesis, which is another name for this idea, says that alien societies might watch us from afar, like how we watch animals in the wild. They could also use ways of talking or technology that we haven't been able to figure out yet. For example, they might be able to talk to each other using quantum entanglement or other complex technologies that are beyond what we currently understand in science. It's also possible that we are the only intelligent beings in the world, or that we are the first intelligent civilization ever to form. If this is true, then it is our duty alone to make sure that intelligent life survives and grows. On the other hand, we might not be the ones watching, but the ones being watched by beings so advanced that their activities look like natural events. The panspermia theory gives us yet another view. This idea says that comets, asteroids, or even microscopic particles could carry life, or at least its building parts through space. If this is true, life on Earth might not have started here, but rather with stuff from other planets. This makes it more likely that life is linked to each other across the universe in more ways than we think. Finding life on Proxima B whether it's microbes or intelligent beings, would have huge effects on Earth. In the first place, it would prove that Earth is not the only place where life can start, and that life can start in many places in the universe. Such a discovery would completely change how we think about biology, evolution, and how life began. If intelligent life is found, the effects will be even more shocking. The very idea of another advanced society would make people question their belief that they are unique and better than other species. It would also bring up important issues about ethics, collaboration, and living together. Should we try to get in touch with them? If so, how can we be sure that others know what we mean? What if they think we are dangerous? Finding life on other planets could also bring people together. We have been split up for hundreds of years by borders, beliefs, and wars. As we come to see ourselves as a single species in a huge, interconnected universe, the understanding that we are not alone may give us a new sense of humanity. From a scientific point of view, looking into life on other planets could change many fields, from health to technology. For instance, learning how life can live on Proxima B's harsh conditions could lead to big steps forward in biotechnology, genetics, and even climate science. There are as many options as there are stars in the universe. Lastly, finding life on other planets would change the way people see their place in the world. Since the beginning of time, people have looked up at the stars and thought if someone or something is watching them. Proxima B gets us closer to the answer to that question and suggests that life may be more varied and widespread than we thought. These big questions are now closer to being answered than ever thanks to the James Webb Space Telescope. The things it sees of Proxima B give us a fascinating look into what might be beyond our solar system. Proxima B could forever change how we see ourselves and our place in the universe, whether it's through the flickering lights of an alien city or the microbes that live in the oceans below the surface. There is one thing we know for sure. The world is much stranger, more complicated, and more beautiful than we ever thought. Also, who knows? We might be about to find out the next big thing. Thanks for watching. If you like this deep dive into the universe, please like, share, and subscribe to our channel. Don't forget to look at the movie that's showing up now. Unknown Trip That Blows Your Mind.